Good morning to one and all. See this today in this live lecture we shall discuss the next part, that is curves and surfaces. But before starting the curves and surfaces, we shall prove the method for formation of a partial differential equation. That is the second method for the formation of a partial differential equation by using the elimination of the function. Actually, we have to study the curves and surfaces. Actually, this is the theoretical part. ये देखो यहाँ पे ये जो पार्ट है ये completely theoretical part है. Now we have to discuss curves and surfaces here. The classification of the first order partial differential equation we have discussed already. Now formation of the partial differential equation. Actually there are two methods for the formation of a partial differential equation. First method is formation of a partial differential equation by eliminating arbitrary constant. This is the first method which we have discussed. This is the second method today we shall discuss, that is a formation method number second. What is that method here? This is the second method. Formation of a partial differential equation by eliminating arbitrary constants here. By eliminating arbitrary constant. Yesterday we have seen formation of a partial differential equation. Formation of a partial differential equation we have yesterday discussed. In that method we have discussed three parts, three cases when arbitrary constant, number of arbitrary constants are less than number of independent variables. Second case, number of arbitrary constants are equal to the number of independent variables, and third case, number of arbitrary constants are greater than the number of independent variable. Now this is the second method. Formation, see this, formation of partial differential equation by eliminating arbitrary constants, arbitrary function phi from the equation phi of u comma v is equals to 0, where u and v are the functions of x comma y comma z. Now proof, how to form? We have to prove this result, how to form the partial differential equation by eliminating arbitrary function. So given, we have given that phi of u comma v is equals to 0. Suppose that z is an independent variable and x comma y are the independent variables, so that according to the particular notation we can write dou z by dou x equals to p, dou z by dou y equals to q, and dou z by dou y by dou x which is equals to 0 because y is independent with respect to x, so its derivative is 0. Dou x by dou y, x is independent with respect to y which is equals to 0. So now we differentiating here. Now we differentiating equation 1. Now if we differentiate this equation 1 with respect, partially with respect to x, because phi is a function of u and v, again u and v are the functions of x and y comma z. So we have to partially differentiate this equation phi of u comma v which is equals to 0, dou phi by dou u into dou u by dou x into dou x by dou x, because u is again a function of x, plus dou u by dou y into dou y by dou x, because u is again a function of x comma y comma z. So first of all we can differentiate dou phi by dou u but u is a function of x comma y comma z, so we can write dou u by dou x into dou x by dou x plus dou u by dou y into dou y by dou x, because u is a function of y and we have to differentiate y with respect to x, plus dou u by dou z into dou z by dou x, because we are differentiating partially with respect to x, plus again phi is a function of v, so dou phi by dou v into dou v by dou x into dou x by dou x plus dou v by dou y into dou y by dou y plus dou v by dou z into dou z by dou x, which is equals to 0. Actually we know that the value of dou x by dou x means 1, so replace this as a 1. Dou u by dou y by dou x, see this, which will be 0, dou y by dou x will be 0, this is 1, this will be 0, and dou z by dou x, which is denoted by p, dou z by dou x, which is denoted by p, so we get the relation dou phi by dou u, this completely becomes dou phi by dou u into dou u by dou x plus p into dou u by dou z, plus similarly dou x by dou x means 1, dou y by dou x means again 0, and dou z by dou x means again p, so we get the second term dou phi by dou v into dou v by dx plus dou x plus p into dou v by dou z, which is equals to 0. Now transfer this term on right side, so we will get dou phi by dou u upon dou phi by dou v, डिव्हिजन मध्ये आणा, म्हणजेच असं होईल, कसं येईल पात टर्म कशी असेल ती, dou phi by dou u into dou u by dou x plus p into dou u by dou z, which is equals to minus dou phi by dou v into dou v by dou x plus p into dou v by dou z. So you can take this in the division, so dou phi by dou u divided by dou phi by dou v, which is equals to minus, हे इकडे डिव्हिजन मध्ये घ्या, dou v by dou x plus p into dou v by dou z divided by dou u by dou x plus p into dou u by dou z. Suppose this is equation number 3. We consider this equation number, suppose, okay, this is equation number 2. We consider this equation number 2, so we can write from 2. Since we can write from 2, so we get this. Similarly, differentiating equation 1 partially with respect to, similarly differentiating equation 1 partially with respect to y, then we get the same relation 3, similarly replace x by y, then same relation we will get, and that will be dou phi by dou, say this, dou phi by dou u divided by dou phi by dou v, which is equals to minus dou v by dou y plus q into dou v by dou z divided by dou u by dou x plus q into dou u by dou z. Suppose this is equation number 4. Now we have to solve equation 1 and 2, sorry, equation 3 and 4. We have to eliminate 5 from equation 3 and 4. Observe that the left side of equation 3 and left side of equation 4 are same, so we can compare the right sides from equation 3 and 4. So it will be dou u by dou v by dou x plus p into dou v by dou z divided by dou u by dou x plus p dou u by dou z, which is equals to dou v by dou y plus q into dou v by dou z divided by dou u by dou y plus q into dou v u by dou z. आता क्रॉस मल्टिप्लिकेशन घ्या. क्रॉस मल्टिप्लिकेशन means we have to transfer this term on left side and this term on right side in the multiplication. So we will get dou u by dou y into q into dou u by dou z bracket close into dou v by dou x plus p into dou v by dou z, which is equals to dou u by dou x plus p into dou u by dou z into dou v by dou y plus q into dou v by dou z. If we take the multiplication, आता याचं multiplication घ्या. Multiplication of two bracket means dou u by dou y into dou v by dou x plus p into dou v by dou z into dou v by dou y plus q into dou u by dou z into dou v by dou x plus q into dou u by dou z into p into dou v by dou z means pq into dou u by dou z dou v by dou z. So then we will get the left side. Similarly, we can take the multiplication. Then we will get the different terms. Now take the common small p and small q from the left side and transfer the terms on left side and right side. Calculate this. याला simplify करा, multiplication करा. स्मॉल पी आणि स्मॉल क्यूच्या टर्म लेफ्टला घ्या, बाकीच्या टर्म राईटला घ्या. मग पीचा जो स्मॉल पीचा जो कोएफिशियंट आहे दॅट इज कन्सिडर्ड ॲज अ कॅपिटल पी. The coefficient of small q is considered as a capital Q and right side is completely considered as a capital R. Then we will get the partial differential equation which is of the form capital P into small p plus capital Q into small q which is equals to R. This is the formation of a partial differential equation by eliminating arbitrary function phi of x comma phi of u comma v. So here p is considered as capital P is considered dou u by dou y into dou v by dou z minus dou u by dou z into dou v by dou y. म्हणजे हा कॅपिटल p into स्मॉल p म्हणजे इथं याचा कोएफिशिएंट स्मॉल p येतो. ठीक आहे. यू कॅन अंडरस्टूड दिस. हे तुम्हाला समजून जाईल, काही अवघड नाही. फक्त मल्टिप्लिकेशन करायचं ब्रॅकेटचं. स्मॉल पी आणि स्मॉल क्यूच्या टर्म लेफ्टला घ्या, स्मॉल पी स्मॉल क्यू कॉमन काढा. स्मॉल पीचा कोएफिशिएंट जो काही असेल त्याला कॅपिटल पी कन्सिडर करा, स्मॉल क्यूचा कोएफिशिएंट जो काही असेल तो कॅपिटल क्यू कन्सिडर करा, राईट साईडची जी काही टर्म असेल ते कॅपिटल आर करा. म्हणजेच वी विल गेट द पार्शियल डिफरन्शियल इक्वेशन विच इज ऑफ द फॉर्म पी कॅपिटल पी इंटू स्मॉल पी plus capital Q into small q which is equals to R. This is the important partial differential equation which is obtained by eliminating arbitrary function phi of u comma v. Okay. Now thus we obtain the linear partial differential equation of a first order and first degree in P and Q. Note that, see this, write down note, if the given equation between x comma y comma z contains two arbitrary functions, then the general their elimination gives rise equations of higher order. या कंडिशन नुसार हायर ऑर्डर इक्वेशन आपल्याला मिळू शकेल if this condition satisfies. Note, then their elimination gives rise the equation of higher order. See this. This is the method, second method for finding the partial differential equation, formation of the partial differential equation by eliminating arbitrary constant. And in the last lecture we have seen that, already we have seen that the formation of the partial differential equation by eliminating arbitrary constant. In this method we have discussed three different cases and we have also solved the examples. Now this is the one theorem or this is the theory in which we have to form the partial differential equation by eliminating arbitrary function which is of the form phi of u comma v is equals to 0, where u and v are the functions of x comma y and z. Okay, so this completes the proof. आता याच्यावरचे प्रॉब्लेम्स वगैरे आपल्याला घ्यायचे आहेत, ते प्रॉब्लेम्स आपल्याला सिलेबस मध्ये आहेत, ते प्रॉब्लेम्स आपण नंतर घेऊ. Now we shall discuss the curves and surfaces. Second part we have to discuss what is meant by the curves and surfaces. Actually, in this section we shall describe two geometrical objects through curves and surfaces, because if there exists one dependent variable and two independent variables, or if there exists a function having three variables, then it will form surface. We have discussed this in the first lecture. आपण फर्स्ट लेक्चर मध्ये आपण हे डिस्कस केलेलं आहे. There is a relation between partial derivative, because the partial derivative exists if there exist two or more independent variable. If there exist two or more independent variable, then we have to discuss the point in a space. If we have to discuss a point in a space, then there exists a surface. There is a relation. See this. There is a relation between the surface and the partial differential equation. That means we have to, before studying the partial differential equation, we must know the concept of the surfaces, and already we have discussed the concept of a surfaces in the first lecture, second lecture, in the basic idea of the partial differential equation. So the surfaces and curves plays a very important role in the study of a partial differential equation. See this introduction. Now we shall write 1 minute introduction. Introduction. Now we shall discuss this 1 minute. In this section, we shall discuss two geometrical objects which are curves and surfaces. Actually, they play very important role in the study of partial differential equation. Partial differential equation. See this. Now we shall discuss the examples also, but we know that curve in 2D. Actually, we know that how to plot the curve in 2D. Suppose this is x-axis having a independent variable small x, y-axis dependent variable. There is only one dependent variable y. There is only one independent variable x. then the relation between x and y, function of the form y is equals to f of x, which gives a curve. This is called as a function. This is suppose x and this is suppose y. The point on the curve. P is any point on the curve. So in this case, this is called as a curve in two-dimensional space. And here the function y is equals to f of x is in such a way that y is a dependent variable and x is an independent variable. So if we want to take the differentiation here, for example, suppose here we consider the example, suppose y is equals to whatever may be x square plus 4, x square plus 2, whatever may be, 4x minus 1, kai kashan. If we want to differentiate this function, then we have to differentiate with ordinary, because if there is only one independent variable, then we have to differentiate that function ordinary. That means dy by dx, which is equals to 2x plus 4, and which gives a tangent at slope of a tangent at a point P. So it will be the dy by dx, slope of a tangent at a point P. So dy by dx means actually slope. This is the concept of ordinary derivative. But now we have to move towards the function in such a way that it includes two or more variables, two or more independent variables. Then we shall discuss the curve in two dimension. So curve in two dimension. Curves in space or 3D. We can write curves in 3D. Now how to calculate the curves in 3D? See, this is very important. काय असतं रे स्टुडंट सांगा बरं, व्हॉट इज मीन बाय हाऊ टू प्लॉट द कर्व्स इन 3 डायमेन्शन मध्ये कर्व्स कसे असतात? ॲक्च्युअली इफ देर इज अ फंक्शन इन द 3 डायमेन्शन, then there exists, so we consider the function z is equals to f of x comma y. This is one function. So we consider this is the z1 f of x comma y. Suppose z2 which is equals to f of x comma y. Another, there are two different functions. F consider करू, g consider करू. There are two. Here in this case, z1 is dependent variable, which is a function of x comma y. z2 is another function, which is function from g of x comma y. Then we can plot the graph in 3-dimensional geometry. See this is very important. So suppose this is a x-axis, this is a y-axis. Suppose this is x-axis, this is a y-axis, this is a z-axis. Then there exists one point. We consider that point is a x comma y. Suppose this is a point P x comma y. Now its z coordinate is 0, so we can write this as a 0. But for corresponding this point, there exists a value z. So there is a considered as another curve. So that will be the surface. We get the point on the surface. So this will be the surface. And this point will be the surface. This point, suppose that will be the surface. Suppose we consider this point is R of x comma y comma z. But suppose this function is considered as z1 is equals to, अरे z1 नकोच आहे, झडच समजा ना, z1 कशाला, आणखी झडच घेऊ ना, z. Okay, this is z is equals to, suppose this z is equals to f of x comma y. This is the first function which is the surface. Now I am going to explain the concept of curve in 3-dimensional geometry. 2-dimensional geometry मध्ये कर्व म्हणजे खूप इजी असतो, पण 3-dimensional geometryचा कर्व कशा पद्धतीत असतो हे आपण सांगतोय. Now we suppose that there exists another function g such that, suppose this is a g will be, we consider this will be the g. Okay, 1 minute, I shall plot the another surface for z. Suppose this is a surface, समजा दोन surfaces आहेत as like this. So this is a surface z is equals to g of x comma y. Then the intersection point, आता या दोन कर्व मधला intersection जो part असतो, this part, intersection जो part असतो पहा, this intersection part gives a curve. This intersection, see this. मी वाटलं तर कलर बदलतो, कलर लक्षात येईल का दुसरा घेतला तर तुम्हाला, रेड कलर लक्षात येईल का रे. सो दिस इंटरसेक्शन पार्ट which will be the curve. हा जो intersection part असतो, this is a curve in 3 space. Curve in 3 dimension. So this intersection part is called, suppose this is the first surface z of f of x, z is equals to f of x comma y. This is the second surface, z is equals to g of x comma y. If we consider the intersection of two surfaces, then the common locus of the common points of two surfaces which gives a curve in 3-dimensional geometry. 3-dimensional geometry. And the partial derivative which gives slope of a tangent to the curve. Slope of a tangent to the curve. Okay, slope of a tangent to the curve. एकच फंक्शन असेल तर त्या फंक्शन वरचा पर्टिक्युलर लोकेशन जर घेतला तर तो सुद्धा कर्व असतो. सपोज दिस इज अ सिंगल फंक्शन z is equals to f of x comma y. z is equals to f of x comma y. If we differentiate partially with respect to x, if we consider y x is a constant, if we differentiate partially with respect to x, then we have to suppose y is a constant, then we get a curve, then also we will get the curve in 3-dimensional geometry which is a parallel to the, which having a constant value for the z, so which is a parallel to the y-axis. See this, in this way we can obtain this. अशा पद्धतीने curves in 3-dimensional geometry means it is the intersection of two curves. हे एक सिंपल आहे. सिंगल जरी तुम्ही हे घेतलात, सिंगल जरी एखादा फंक्शन 3-dimensional geometry घेतलात, if we consider a single function z is equals to f of x comma y, then it will be a surface. If we differentiate partially with respect to x, then there exists a curve tangent to the curve at particular point to that curve. We have already seen this in the second lecture. what is the relation between partial derivative and the tangent to the curve of the surface. Tangent to the curve of the surface we have already discussed. So you note that curve is the, generally curve in three-dimensional space is the intersection of the locus of the two surfaces. Okay, now we shall discuss this concept. So we can write the curve in the space means which is the intersection of the two surfaces. So here the curve, I shall write, 1 minute. So the curve is therefore the curve, a curve is, आपण द म्हणण्याऐवजी a curve is, 1 minute, a curve is thought of, a curve can be thought of as the points of intersection of two surfaces. This is the idea about the curve. Okay, now we shall move towards this. Now curve in space. आता ही theory कशी होते पहा, आपण हे डायग्राम मध्ये दाखवलेलं आहे. Now we shall discuss the curve in space. 1 minute, I shall take this. Actually this is a completely theoretical part. Now see this curve in space. Now we can represent curve in space by using the parametric equation. So a curve may be specified by means of a parametric equation. We can represent this curve by using the parametric equation. Suppose f1, f2 and f3 are continuous functions of a continuous variable t. Here t is called as a parameter which varies in an interval I, which belongs to, which is a subset of R. So t is belongs to I, which is given, so which is subset of R. Then the three equations, we can write these three equations. X is equals to f1 of t, y is equals to f2 of t, z is equals to f3 of t, represents the parametric equation of the curve in three-dimensional space. This is the concept of equation of the parametric equation of a curve in the three-dimensional space. Or we can write in this way also. आपल्याला असं सुद्धा लिहिता येतं. We can write this. Suppose x is equals to f of t, y is equals to g of t, z is equals to h of t, where t is the parameter. Then this equation represents parametric equation of curve. So the equation 1 represents parametric equation of curve. Means we can use different methodology to represent curve in three-dimensional geometry. In space means in three-dimensional geometry. Means is like this, curve in three-dimensional geometry. But this is the equation in terms of parametric form. X is equals to f of t, y is equals to g of t, z is equals to h of t. So t is called as a parameter which is belong to the, see this, t belongs to interval I which is a subset of R, set of real number. Okay. So this equation 1 is called as a parametric equation of the curve in the 3-dimensional geometry. हे एक definitions आहे, ते लक्षात ठेवा. Now a standard parameter is the length of a curve measured from a fixed point on the curve. If we consider fixed point on the curve, suppose that point is called as a x comma r comma x. R is a point having a coordinate x comma y comma z. Then the length of that point from the, so fixed point that is r x comma y comma z. The standard parameter is the length of the curve measured from some fixed point on the curve. In such cases, that at times the symbol s is also used instead of t. S च्या जागी आपण t सुद्धा वापरू शकतो. So the condition that the parameter t is the length of curve is f dash square, f1 dash square plus f2 dash square plus f3 dash square. So or dx by dt bracket square dy by dt bracket square plus dy by dz by dt bracket square, which is equals to 1, which gives the length of the curve from fixed point, where the prime denotes the differentiation, म्हणजे dash means the differentiation. Okay, this is the concept of a curve in space. ही जी concept आहे तो parametric curve. हे theory आहे, तुम्ही लक्षात ठेवा. This is the concept of a curve in space or in 3-dimensional geometry in the form of a parametric form. Example, the simplest examples here of a curve in a space is a straight line. Space मध्ये simple example of the curve is in a straight line. See this. Suppose this is a z-axis. Suppose this is a x-axis. This is also y-axis. Curve in a straight line with direction cosine. Suppose this is a lineal. You can take a lineal. So L is already given. So we consider P, small p. This is the line in a 3-dimensional geometry. This is y-axis. This is the z-axis. Angle with this is alpha. Angle with this y-axis is a beta. Angle with the z-axis is a gamma. Then cos alpha is equals to L. Cos beta is equals to m, and cos gamma is equals to n. These are the direction cosines of a line which is passing through the point. Suppose that point is considered as a P. Suppose this is a fixed point which is denoted by x0, y0, z0. Then we can write the equation of a curve. Parametric equation of a curve is, curve means line. This is a line which can write x minus x0, which is plus ls, comma y is equals to y0 plus ms, z is equals to z0 plus ns, where s is a constant which is belongs to R. Or this can be also written as, याला असं सुद्धा लिहिता येतं, पण पॅरामेट्रिक फॉर्म मध्ये नाही, कार्टेशियन फॉर्म मध्ये असं लिहिता येतं. वी कॅन राईट इन द कार्टेशियन फॉर्म x minus x0 divided by L which is equals to y minus y0 divided by m, which is equals to z minus z0 divided by n, which is equals to s. This is also the equation of a curve. We consider that curve. Simplest example of the curve is this. So this is the parametric Cartesian equation of the curve. This is the parametric equation. X is equals to x0 plus L s, comma y is equals to y0 plus ms, z is equals to z0 plus ns, where L, M, N are the direction cosines of a given curve or a given curve with respect to the coordinate axis. Okay, given curve and x0, y0, z0 is a fixed point, then we can write this equation, parametric equation of simple curve in the 3-dimensional geometry. Okay, हे एक एक्झाम्पल सांगितले, काही अडचण नाही, फक्त तुम्हाला एक्झाम्पल माहित राहावं. आणि दिस इज द कार्टेशियन इक्वेशन. बाजूला मी जे कार्टेशियन इक्वेशन लिहिलेलं आहे. सो वी शॅल राईट दिस. नाउ सेकंड एक्झाम्पल, राइट सर्क्युलर हेलिक्स इज a space curve lies on a circular cylinder and is given by the parametric equation x is equals to a cos omega t. A means here this is the radius which is a constant. A म्हणजे काय मी इथे लिहितो. You can draw this diagram also. A means the radius, this length. This is called as a. ही जी लेंथ असते ना त्याला ए म्हणू. ओमेगा, ओमेगा means the angular rate of change of angular velocity. That means omega. See this is omega. Angular speed it is also called as t means the parameter. So the equation in 3-dimensional geometry, we consider a surface or the curve. We consider the curve. See this, we have denoted this curve. हे black line न दाखवलेला जो curve आहे ना, त्या curveचं इक्वेशन कसं येतं पहा. See this is the curve. So we consider this curve. Equation of this curve, x is equals to a cos omega t, y is equals to a sin omega t, and z is equals to kt. This is the curve. Means curve which is represented by the black line and which is given by a right circular helix in a space, curve lying on a right circular cylinder whose equation, parametric equation is given this. हे फक्त एक्झाम्पल आहे, तुम्ही लक्षात ठेवा. आता इथं पहा, तुम्हाला लक्षात यायला पाहिजे, यामध्ये जो ब्लॅक लाईन दाखवलेली आहे, दिस ब्लॅक कर्व, द इक्वेशन ऑफ दिस ब्लॅक कर्व इज गिवन बाय इन द पॅरामेट्रिक फॉर्म x इज इक्वल्स टू a cos omega t, y इज इक्वल्स टू a sin omega t, z इज इक्वल्स टू kt. T belongs to R. T is the constant which belongs to R. Now we shall discuss the next part, that is the surfaces. हा theoretical part आहे, फक्त लिहून घ्या तुम्ही. So we consider the next part, that is the surfaces. A point x comma y comma z in space is said to lie on the surface if the coordinates x comma y comma z satisfies this equation, this function f of x comma y comma z. See this. Suppose that this R, in this example suppose R, this point R is said to be on the surface first, then this point x comma y comma z satisfies the function f of x comma y comma z. This is the conditions here. So function, आता हे तुम्हाला सर्वांना माहित आहे, फक्त थेरी आहे, लिहून घ्या, f of x comma y comma z. where f is a continuous differentiable function defined on a domain in R3. Therefore, a surface is the locus. Surface is the locus of a point moving in a space with 2 degree of freedom. What is meant by degree of freedom? A function which can be represented, which can be specified by using minimum number of independent variables. Minimum number of independent variables. See, this z is equals to f of x comma y. So here in this case we have required minimum 2 independent variable. If a function which is of the form, suppose x square plus y square plus z square, which is equals to suppose 1, this is a function of 3-dimensional geometry. We can specify this function by using minimum 2 independent variable. That means we have given 2 degree of freedom. Degree of freedom means which requires function which can be specified by using minimum number of independent variable. Means we have required minimum 2 independent variable. तुम्हाला जर हे फंक्शन डिफाइन करायचं असेल तर कमीत कमी 2 तुम्हाला इंडिपेंडंट व्हेरिएबल्स माहित पाहिजेत. कमीत कमी 2 व्हेरिएबल तरी माहित पाहिजेत, म्हणजे तिसरा व्हेरिएबल आपण फिक्स करू शकतो. सो कन्सिडर द सेट ऑफ रिलेशन्स ऑफ द फॉर्म x is equals to f1u comma v, y is equals to f2u comma v, z is equals to f3u comma v. Suppose this is equation number 3, where u and v are the functions of, if this is x, then y, x, yz, zx, xy, in this way. So now we consider the another here, 1 minute. So then each pair of values of u and v corresponds 3 numbers x comma y comma z, and hence the point x comma y comma z in a space. It is however not true that every point in space corresponding to the pair of u and v. असं पण नाही आहे की प्रत्येक पॉइंट u आणि v ने स्पेसिफाय होतो. If the condition of Jacobi, we have seen in the B.Sc second year, condition for the Jacobian. So dou f1 comma f2 divided by dou u comma v, which is equals to dou f1 divided by dou u into dou f2 divided by dou v minus dou f1 divided by dou v minus dou f2 divided by dou v, which is not equals to 0. Then the first 2 equations from equation 2 can be solved to express u and v as a functions of x and y locally. Already हे आपण discuss केलेलं आहे. You have studied in the syllabus of a B.Sc. We say that u is equals to lambda of x comma y, v is equals to mu of x comma y. By using this we can find the values of u and y, u and v, u and v by the inverse function theorem. Then u and v are determined once x and y are known, and the third equation in 2, आता तिसरा जो इक्वेशन आहे 2 मधला जो थर्ड इक्वेशन आहे, which gives here, which gives a value of z for these values of x and y, that is z is equals to f3 of, now replace the value of u is in the 3, see this, replace the value in the 3, z is equals to f3 of u comma v, but u comma v can be obtained from equation 1 and 2 in the form of x and y, and that are u is equals to lambda x comma y, v is equals to mu x comma y. So we can write third equation from 2, z is equals to f3 of lambda x comma y comma mu x comma y. So which is thus a functional relation between the coordinates of x comma y and z as in equation 1, represented by the equation 1. Okay, so Thus, any point x comma y comma z, we can define any point x comma y comma z determined from the equation 2 always lies on a fixed surface. For this reason, equation of the type 2 is called parametric equation of the surface. So, equation 2 is called as a parametric equation of the surface. This is the parametric equation of the surface. Okay. So, however, the parametric equation of surface are not unique as the following example. म्हणजे पॅरामेट्रिक इक्वेशन ऑफ सर्फे हा युनिकच असतो नाही, वेगवेगळे सुद्धा असू शकतात. त्याचे एक्झाम्पल्स दिलेले आहेत. एका सरफेससाठी पॅरामेट्रिक इक्वेशन आपण वेगवेगळ्या फॉर्ममध्ये लिहू शकतो. थीटामध्ये लिहू शकतो, टी मध्ये लिहू शकतो. यू नो दॅट द स्टँडर्ड इक्वेशन ऑफ अ सर्कल इज एक्स स्क्वेअर. पॅराबोलाचं इक्वेशन आहे, आपण पॅराबोलाचं स्टँडर्ड इक्वेशन ऑफ सर्कल इज एक्स स्क्वेअर प्लस वाय स्क्वेअर इज इक्वल्स टू 1. X square sphere is x square plus y square plus z square is equals to 1. We can write in the form of t. We can write in the form of a theta also, cos theta sin theta. So we can see this note. However, the parametric equations of a surface are not unique. As we can example. आता example पा एक example दिलेला आहे. Parametric equation of surface is not unique. So we consider the example. See this, which is represent not unique. Parametric is not unique. The parametric equations x is equals to a sin u cos u, y is equals to a sin u sin v, z is equals to a cos v. And we can write this x is equals to a into 1 minus v square divided by 1 plus v square into cos u. Y is equals to a into 1 minus v square divided by 1 plus v square into sin u, which is equals to 2av divided by 1 plus v square, where a is the constant. Both represents the surface. See this. See this. This is equation number 1. This is a parametric equation of a surface. This is also the parametric equation of the same surface, which is given by equation number 3. म्हणजे equation 1 and equation 2 are the parametric equations, two different parametric equations of the surface x square plus y square plus z square is equals to a square. तुम्ही सॉल्व करू शकता. Means first equation also satisfies equation 3, second equation also satisfies equation 3. So first equation is called as a parametric equation of a surface 3. Second equation is also parametric equation of surface 3. So equation 3 has two